Tonight, we're going to dismantle an image that's been sitting in your mind since childhood. An image so gentle, so quiet, so comforting, that most people never think to question it. You've seen it 1,000 times in textbooks, in classroom posters, in the soft blue light of a documentary playing late at night. A small silver spacecraft, no larger than a compact car, drifting through the endless dark. A tiny golden disk bolted to its side. A polite little machine waving goodbye to Earth, slipping quietly into the void. Peaceful, silent, alone. That image is wrong, not partially wrong, not slightly outdated. Wrong in a way that changes everything you thought you knew about the edge of our solar system, about the space between the stars, about what it means for a machine to go dark 12 billion miles from home. Because in the final years before its instruments began to fail, Voyager 2 was not drifting through emptiness. It was passing through something. It was recording something. And what it recorded, in the seconds and hours and years before the signal grew faint, is stranger and more haunting than anything the engineers who built it could have imagined when they sealed the golden disk to its side in the summer of 1977. So tonight, I want you to sit with a question. A single question, so strange it might keep you up long after this video ends. A question that has no clean answer, only deeper and deeper layers, each one making the last one feel small. What was Voyager 2 listening to in the moments before it went silent? Not what it saw, not what it photographed, what it heard. Because Voyager 2 has ears. It always did. And what those ears picked up, at the boundary between our sun's territory and the wider galaxy, was not the silence you were told about in school. It was something else. Something no human instrument had ever recorded before. Something that, once you understand what it is and where it came from, will change the way you look at the night sky for the rest of your life. We're going to go there together, but not all at once. Because to understand what Voyager 2 recorded, you first have to understand where it is. And to understand where it is, you have to let go of every mental picture you've ever had of our solar system. The tidy poster with the 9 planets in a neat row. The comforting diagram of orbits like rings on a target. The soft assumption that beyond Pluto there is nothing, just cold, empty, endless dark. That picture is not just incomplete. It's a story we tell children so they can sleep at night. The truth is larger and stranger and more beautiful than the story. And the little spacecraft we launched in 1977, this humble machine built with the computing power of a modern car key, has spent nearly half a century quietly proving it. One measurement at a time. One whisper at a time. Across a distance so vast that its own voice, traveling at the speed of light, now takes more than 20 hours to reach us. 20 hours. Let that sit with you for a moment. If you sent a message to Voyager 2 right now, and it answered you the instant it arrived, you would be nearly 2 days older by the time you heard the reply. Not because the machine is slow, because the space between us is enormous. And every year, every hour, every second, that space grows larger. Voyager 2 is falling away from us at more than 15 kilometers per second, 9 miles every second. and it is never coming back. Before we go any further, I want to ask you a small favor. If this kind of slow, deep, contemplative exploration is the kind of thing you love, if you're the kind of person who sits with the strange and the vast and the not quite knowable, then a quick like or a subscribe genuinely helps this channel keep making these long, careful videos. It's a small thing on your end. It makes a real difference on mine. That's the only time I'll ask until the very end. Now let's begin, because here is what we're going to do tonight. We are going to follow Voyager 2 outward, layer by layer, from the familiar into the unfamiliar. We are going to walk through the 2 times it went dark, the 2 silences that shook the mission control room in ways the public never really understood. We are going to stand with Voyager 2 as it crossed a wall of superheated plasma at the edge of our sun's territory. A wall so hot it registers at tens of thousands of degrees, and yet somehow did not burn the spacecraft alive. We are going to listen together to the hum it recorded on the other side of that wall, a hum that no human ear has ever heard directly, but which every human being who has ever lived has been surrounded by, without knowing it, since the moment they were born. And then we are going to zoom out further. We are going to see that the wall Voyager 2 crossed is not the edge of anything, really. It is only the edge of our sun's small pocket, drifting inside a much larger cloud, which itself is drifting inside a cavity carved into the galaxy by the deaths of ancient stars. Stars that exploded before humans had language, before humans had fire, before humans existed at all. And you and I, right now in this room on this planet, are sitting inside that cavity. We always have been, and we are going to end hours from now at the place where the question dissolves. Because the strangest thing about Voyager 2, stranger even than what it recorded, is what will happen to it after the last instrument shuts down, after the plutonium finally runs cold, after the signal fades below the noise for the very last time. Voyager 2 will not stop. It will not slow. It will keep moving at 9 miles per second for tens of thousands of years, then hundreds of thousands, then millions. It will still be moving when the sun begins to die. It will still be moving when the earth is swallowed. It will still be moving when the human species, whatever we become, is a memory older than the pyramids are to us now. Voyager 2 is not just a spacecraft. It is a fossil we launched before we knew what a fossil was. And what it recorded in the seconds before each of its little silences is a message we are only just beginning to understand. So before we go further, I want you to hold something in your mind. When you were a child, when you first heard the name Voyager, what did you imagine? Did you picture a little robot with a face? Did you imagine it lonely? Did you imagine it brave? Did you imagine, somewhere deep down, that it was still out there, waiting for someone to find it? Whatever you pictured, hold on to it. Because in the next hour and a half, we are going to replace that picture with something truer and stranger, and in a way that will surprise you, more tender than the story you were told. Stay with me. We're only just beginning. Let's begin with the story you already know, or more accurately, the story you think you know. Because almost everything we tell each other about Voyager 2 is a kind of shorthand, a postcard version of a much stranger truth. The postcard goes like this. In the summer of 1977, on August 20th, a Titan IIIe rocket rose from Cape Canaveral into a clear Florida sky, carrying a small, spindly spacecraft into the black. Its twin, Voyager 1, would follow 16 days later, on September 5th, on a faster trajectory that would eventually let it overtake its older sibling. The mission was called the Grand Tour, a once-in-176-year alignment of the outer planets, Jupiter, Saturn, Uranus, Neptune, arranged in such a way that a single spacecraft could visit all four by slingshotting from one to the next, borrowing a little velocity from each. Miss the window and you would wait almost 2 human lifetimes for the next one, so they built the Voyagers, and they aimed them at Jupiter and they let go. You know the greatest hits. Jupiter's great red spot, that impossible storm larger than our whole planet, photographed in colors no human eye had ever seen before. The volcanoes of Io, still erupting, still active, when everyone had assumed the moons of the outer planets would be cold and dead. The strange smooth ice of Europa, cracked like a shattered plate glued back together, hinting at an ocean beneath. Saturn's rings, revealed for the first time to be not solid but a swirling, layered, gravitationally sculpted mosaic of ice and rock. And then, only for Voyager 2, the two worlds no other spacecraft had ever visited, or has visited since. Uranus, tilted on its side like a spinning top knocked over, its faint rings and its handful of moons appearing in the darkness as pale, ghostly disks. And Neptune, deep blue, wind-blasted, with a storm called the Great Dark Spot roaring across its face at speeds no meteorologist on Earth could quite believe. Voyager 2 saw all of these. Voyager 2 was the only spacecraft that ever has. And then, the postcard tells us, it kept going. Out past Neptune, out past the orbit of Pluto, out into the endless dark, carrying on its side that famous golden disk, the golden record, a copper phonograph plated in gold engraved with instructions for how to play it containing greetings in 55 languages, the sounds of Earth. A whale song, a mother kissing her child, a heartbeat, wind, rain, 115 images encoded in analog waveforms, and 90 minutes of music from every corner of the human world. Beethoven's Fifth, Chuck Berry's Johnny Be Good, a Navajo night chant, a Peruvian wedding song, a raga from India, a gamelan from Java, a prelude by Bach. We tell ourselves this record was a message to the stars, a bottle thrown into the cosmic sea, in case somewhere, someday, someone finds it, a message that says we were here, we loved, we sang. We were curious, please remember us, and that more or less is where the popular story ends. A little silver spacecraft, a golden disk, a slow drift into the dark. The engineers who built it are mostly retired now or gone. The children who watched the launch on grainy television screens are grandparents. And Voyager 2, we tell ourselves, is still out there somewhere alone in the peaceful, silent, empty black between the stars. Peaceful, silent, empty. 3 words, 3 assumptions, and every single one of them is wrong. Let's take them one at a time. Because to understand what Voyager 2 has really been doing for the last 5 decades, you have to first let go of the postcard. Start with peaceful. Voyager 2 is not drifting. It is not floating. It is moving through space at more than 15 kilometers per second, roughly 34,000 miles per hour, faster than any bullet, faster than any missile, faster than almost anything human beings have ever made move. And it is being battered, constantly, by the solar wind while it was still inside our sun's territory, by cosmic rays now that it has left, by dust grains, some the size of atoms, some the size of grains of sand, all of them striking the spacecraft at velocities that would vaporize a bullet on impact. Voyager 2 is not resting in stillness. It is sprinting through a storm we cannot see. Then take silent. Voyager 2 has never been silent. Its transmitter has been broadcasting continuously for nearly 50 years. A radio whisper of just 22 watts. Less power than the light bulb in your refrigerator. And yet that whisper, that impossible whisper, is still reaching Earth, night after night, decade after decade, faithfully carrying data from the edge of the known. And on the other side, Voyager 2's own instruments have been listening too, recording, measuring, sampling the plasma around it, the magnetic fields, the cosmic ray flux, the density of charged particles. Not with microphones. There is no air out there to carry sound, but with electromagnetic ears that translate the vibrations of plasma into signals we can, in a strange and beautiful sense, hear. And empty. This is the biggest lie of all. The space Voyager 2 has been traveling through is not empty. It has never been empty. It is thin, yes, thinner than the best vacuum any laboratory on Earth can produce. But thin is not the same as empty. Every cubic centimeter of the space around Voyager 2 right now contains particles, charged particles, hydrogen ions, electrons, traces of helium, cosmic ray protons hurtling in from ancient supernovae, photons streaming out from stars that died before the Earth was born. The space between the stars is a soup. A very thin soup, but a soup nonetheless. And Voyager 2 has spent the last decade and a half tasting it, so let go of the postcard. The little silver spacecraft is real. The golden record is real. The launch happened. The grand tour happened. All of it is true. But the story we tell about what happens after the grand tour, the story of the peaceful, silent drift into nothing, is a story we made up because it comforted us, because it was easier than the truth. The truth is that Voyager 2 has been in a conversation this whole time, a conversation with the space around it, whispers going in, whispers going out, measurements arriving on Earth years, decades after they were recorded. A slow, patient, mostly ignored dialogue between one small machine and the enormity that surrounds it. And in that conversation, something happened. Twice. Voyager 2 stopped speaking. 2 times in the years since it left the planets behind, the signal went dark. And in both cases, the people who had spent their entire adult lives listening to that whisper, watching for it, waiting for it, felt something they had not expected to feel. Grief. Real, sharp human grief. Because when a spacecraft you have known longer than your own children falls silent, 12 billion miles from home, you begin to understand something about what it means to love a machine. But before we talk about those silences, before we walk through what it felt like in the mission control rooms when the whisper stopped, I want you to sit with something. Because if you were going to encode a message on a golden record, if you knew that record might drift for 1 billion years, might be found by something you could not imagine, might be all that ever remained of your species, what would you put on it? Not the greatest hits, not the polished speeches. What would you record from your own life? Would it be a laugh, a door closing, your grandmother's voice? The sound of rain on a specific roof, in a specific city, on a specific afternoon that mattered to you for reasons you could never quite explain to anyone else. What would your golden record sound like? Sit with that. Because the people who built Voyager 2's record had to answer that same question. And the answer they came up with, imperfect as it was, is now the loudest thing humanity has ever sent into the dark. And here is where the story turns. Because for all its beauty, that golden record was never the most important thing bolted to Voyager 2. The most important things were the instruments, the magnetometer, the plasma wave subsystem, the cosmic ray detector. The little silent ears that would spend the next half-century listening, quietly, to a universe we barely understand. And those ears heard something the postcard never prepared us for, something the engineers of 1977 never expected. Something we are still, right now, in the year you are watching this, trying to make sense of. But before we can talk about what Voyager 2 heard, we have to talk about the moments when it stopped speaking. The two darknesses, the two silences. The two times, in the long conversation between a small machine and the enormity around it, when the whisper simply stopped. And on Earth, in a control room in Australia, and in another control room in California, human beings held their breath and waited to see if a machine older than most of them would ever speak again. That is where we go next. To understand what it means for Voyager 2 to go dark, you first have to understand how we listen to it in the first place. Because the way we hear that little whisper from 12 billion miles away is one of the most quietly astonishing feats of engineering on this planet, and almost no one outside a small circle of engineers ever thinks about it. Voyager 2's radio transmitter, as we said, puts out about 22 watts. Think about that for a second. 22 watts. The bulb in the reading lamp beside your bed is probably more powerful. And that faint whisper, that impossibly small trickle of radio energy, has to travel across a distance so vast that by the time it reaches Earth, it has weakened by a factor of trillions upon trillions. The signal that arrives here is not measured in watts or milliwatts or even microwatts. It is measured in attowatts, billionths of a billionth of a watt. It is, by any ordinary measurement, indistinguishable from nothing at all. To catch that nothing, we built a set of ears. 3 of them actually, spaced roughly evenly around the Earth so that as the planet turns, at least one is always facing the outer solar system. This is the Deep Space Network. 3 complexes, one in Goldstone, California, one in Madrid, Spain, and one in Canberra, Australia. Each complex has enormous dish antennas, some of them 70 meters across 70 meters larger than a soccer field engineered to catch signals so faint that if you added up every whisper Voyager 2 has ever sent us across almost 50 years of transmission, the total energy received would not be enough to lift a single grain of sand, a single millimeter off a table. And of those three complexes, only one can hear Voyager 2 at all. Because of the trajectory the spacecraft took after Neptune, its path bends steeply southward, well below the plane of the planets, deep into the southern sky. From the northern hemisphere, Voyager 2 has effectively slipped below the horizon and will never rise again. Only the Canberra Deep Space Communication Complex in the hills outside the Australian capital can point its dish in the right direction. And within that complex, only one dish is powerful enough to send a signal back. A single antenna, dish number 43, DSS 43, 70 meters wide. Older than most of the people who operate it, and the only mouth on Earth that can still speak to Voyager 2. Hold that in your mind for a moment. Not a global network of antennas standing ready, not a fleet of dishes. One antenna, in one country. On one hemisphere of one small planet. That is our entire line of communication with the most distant human-made object ever built. If DSS 43 stops working, Voyager 2 cannot hear us. It can still speak, but it cannot be spoken to, which brings us to the first darkness. In March of 2020, DSS 43 was almost 50 years old. It had been listening and speaking to spacecraft since the 1970s, and its transmitters, its heart, its voice were beginning to fail. The engineers who cared for it made a decision. The dish would go offline for 8 months. It would be repaired, refurbished, upgraded, its heaters replaced, its transmitters rebuilt. And during those 8 months, we would be able to hear Voyager 2 through other, smaller dishes at Canberra, but we would not be able to speak to it. No commands, no updates, no corrections, just listening. For 8 months, the conversation went one way. Voyager 2 whispered and we listened, and we could not answer. If something had gone wrong on the spacecraft during those 8 months, if an instrument had faulted, if a computer had rebooted into a strange state, we would have had no way to help. We could only watch and hope. Now I want you to imagine what that feels like. Not intellectually, emotionally. Imagine you have a friend and this friend has been in your life for longer than most of your family, longer than your marriage if you have one, longer than your career, longer than your children have been alive. And this friend lives so far away that a single letter takes a full day to reach them. And one day you are told, for the next 8 months, you cannot write to them. Only they can write to you. And if they get sick or scared or hurt, you will read about it, but you cannot answer. You cannot say, hold on, we are here, we are trying. You can only read the letters as they arrive and hope the next one comes. That is what those 8 months were like for the Voyager team. Every day, a whisper from Voyager 2 would arrive and they would breathe out. Every day they would check the data and it would say, I am still here. I am still moving. My instruments are still recording. And every day They would want desperately to send a message back, and they could not. DSS-43 came back online, on schedule in early 2021. The first command was sent. The first test signal reached Voyager 2 nearly 18 hours later at the speed of light, and Voyager 2 answered. It had waited. It was still there. The conversation resumed. That was the first darkness. But it was, in a strange way, the gentler one, because it was planned. The engineers knew it was coming. They had prepared, and they knew more or less when it would end. The second darkness was different, because it was not planned at all. It happened on July 21st, 2023. On that day, a routine command was sent to Voyager 2 from Earth. A command to adjust its orientation just slightly, just a small nudge. The engineers had done this many times before, but this time the command contained an error, a tiny mistake in the parameters, not a catastrophic one, just a small shift in the numbers. And when Voyager 2 executed the command, its antenna, the big dish on its side that points toward Earth, rotated by 2 degrees. 2 degrees does not sound like much. Hold your hand out at arm's length. The width of your little finger held against the sky is about 1 degree. Voyager 2's antenna moved 2 of those, a tiny twitch, a shrug, but at a distance of 12 billion miles, 2 degrees is enormous. The narrow cone of the radio signal, aimed at Earth, swept sideways by an amount that put our entire planet outside its reach. Voyager 2 was still transmitting. Its instruments were still recording. Its voice was still going out. But its voice was no longer aimed at us. It was aimed at empty space, drifting past us, missing us entirely unheard. On the morning of July 21st, the Canberra dish went quiet. No whisper arrived. Not that day. Not the day after. Not the day after that. And the engineers realized, with a kind of slow, sickening clarity, what had happened. They had, through a single incorrect command, effectively hung up on Voyager 2. And Voyager 2, which had no way of knowing, was still talking, still recording, still whispering into the dark, its words falling forever past a world it could no longer see. For weeks, there was nothing. The team calculated. If the antenna was pointed 2 degrees off, then even a shout, even the most powerful signal DSS-43 could send, would probably not be strong enough to reach Voyager 2. And even if it did reach the spacecraft, Voyager 2's own pre-programmed routine to reset its antenna orientation was not scheduled to run until October 18th, nearly 3 months away. 3 months of silence. 3 months of hoping the spacecraft's onboard clock and its autonomous routines would, on that specific date, correct the drift and turn its face back toward the sun. And so, in early August, they tried something they were not sure would work. Using DSS-43, they sent what came to be called the Interstellar shout. A single command, aimed as precisely as they could aim it, cranked to the highest power the transmitter could deliver, broadcast into the black in the direction where Voyager 2 was supposed to be. If it worked, the spacecraft would hear a whisper of a shout, notice a signal on the edge of its detection threshold, and reorient its antenna back toward Earth. The signal took over 18 hours to reach Voyager 2. And then another 18 hours would pass before any answer, if there was one, could come back. So for 37 hours, the engineers sat and waited. A day and a half of silence, in an office in California and a control room in Australia. And they did not know if the friend on the other end of the line was still listening. On August 4th, at nearly 1 in the morning California time, the whisper came back. Voyager 2 had heard them. It had turned its face. The signal was locked. The conversation resumed. And when I read the accounts from the engineers who were there, what struck me was not the technical triumph. It was the emotion. Grown people, some of them decades into their careers, some of them who had worked on Voyager since they were young engineers in the 70s, wept. Not because of the machine, because of what the machine represented, because for 37 hours they had thought it might be over, not just the mission, the relationship, the half-century-long, one-directional friendship between a species and a small piece of itself, drifting alone at the edge of the known. Two darknesses, two silences, one planned, one not, and in both the same lesson. That out there at the edge of the sun's territory, Voyager 2 is not simply a data source. It is not simply a spacecraft. It is something more human than that. It is a small, patient voice, whispering back to us from a place none of us will ever see, and every time that voice goes quiet, we remember, with a small ache we cannot quite name, how much we depend on hearing it. So let me ask you something. Have you ever, in your own life, waited for a message from someone very far away? A letter that took weeks to arrive? A phone call across a time zone? A text from someone whose reply you needed more than you wanted to admit? Do you remember what that silence felt like? Do you remember how loud a silence can be when you are listening for a specific voice inside it? Because that is what the Voyager team lived through, on a scale most of us can barely imagine. 37 hours of a silence stretched across 12 billion miles, waiting for a whisper, waiting for a friend. But here is the strange, humbling truth. Those silences, dramatic as they felt on Earth, are nothing compared to what Voyager 2 heard just before them. Because in the years leading up to those darknesses, Voyager 2 had been passing through something extraordinary, something no human-made object had ever passed through before. A boundary, a wall. A crossing so violent in a certain sense that if we had been standing beside the spacecraft, we would not have believed our instruments. There is a wall at the edge of our sun's territory, and Voyager 2 walked through it. That is where we go next. The wall does not look like a wall. If you were standing beside Voyager 2 as it approached, you would see nothing. No shimmering barrier, no visible edge, no line drawn across the black. You would look ahead and you would see stars. You would look behind and you would see stars. And you would have no idea that you were about to cross one of the most important boundaries in our corner of the galaxy. A boundary that took the spacecraft 41 years to reach. To understand what that wall is, you have to first understand where our sun ends. And here is the strange, humbling thing. Our sun does not end at its surface. It does not end at the corona, that fiery outer atmosphere you sometimes see photographed during a total eclipse. It does not end at the orbit of Mercury or Earth or Neptune or Pluto. Our Sun, in a very real sense, extends outward in every direction for tens of billions of miles beyond the last planet, not as light, not as heat, as wind. The solar wind is a stream of charged particles, mostly protons and electrons, blowing outward from the Sun in all directions, all the time at speeds of hundreds of kilometers per second. It is invisible, it is silent, it is thin, but it is constant. And it has been blowing for 4.5 billion years without pause. That wind carves out a vast, roughly spherical bubble around the Sun, a bubble so large it stretches far beyond the orbit of every planet. And inside that bubble, everything, every planet, every asteroid, every comet, you, me, the entire history of life on Earth exists inside the exhaled breath of one particular star. The bubble has a name. We call it the heliosphere, and it has an edge, not a sharp edge. A messy, turbulent, complicated edge, where the Sun's wind finally slows down, presses against the thin gas of interstellar space, and gradually loses the argument. At that edge, the outgoing solar wind meets the incoming gas of the galaxy, and the two press against each other, and neither one entirely wins. The result is a turbulent, dynamic, restless boundary, where the density of particles jumps sharply, where the temperature rises to tens of thousands of degrees, where magnetic fields tangle and twist and reconfigure themselves. That boundary is called the heliopause. And crossing it is the closest thing we have to a border crossing between our Sun's territory and the wider galaxy. Voyager 1 crossed it first. On August 25, 2012, at a distance of about 18 billion kilometers from the Sun, roughly 120 times the distance from the Earth to the Sun, Voyager 1 slipped through the heliopause and became the first human-made object to enter interstellar space. But Voyager 1's plasma instrument had failed years earlier. It could sense that something had changed, but it could not directly measure the density of the plasma around it. We had to infer the crossing from other data. It was a landmark. But it was, in a certain sense, a blind crossing. Voyager 2 crossed second. On November 5, 2018, at a distance of roughly 17.5 billion kilometers from the Sun, 119 astronomical units, Voyager 2 slipped through its own heliopause. And its plasma instrument, the plasma science experiment, still worked. For the first time in human history, we had a functioning, calibrated, real-time plasma detector at the edge of the Sun's territory, watching what happened as a spacecraft crossed from one side to the other. What we saw was startling. Even for the scientists who had spent decades preparing for this moment. The density of charged particles around Voyager 2 jumped, not gradually. In a single day, the density of plasma around the spacecraft rose by roughly a factor of 20. 20 times denser on the other side of that invisible line than on the side facing home. And the temperature of that plasma, measured by the way charged particles wiggled and vibrated against the spacecraft's instruments, was somewhere between 30,000 and 50,000 Kelvin. tens of thousands of degrees. Hotter than the surface of the sun. Let that sit with you. Voyager 2 crossed into a region of space where the ambient temperature is hotter than the surface of the star we orbit. And it did not burn. It did not melt. It did not even notice, really. Its instruments recorded the numbers, transmitted them home, and kept going. How is that possible? How can something be that hot and not destroy the spacecraft passing through it? The answer is one of the most beautiful and counterintuitive facts in physics, and it is worth pausing on. Temperature and heat are not the same thing. Temperature is a measure of how fast the individual particles in a substance are moving. Heat is the total amount of energy those particles can transfer to something else. If you have a room full of extremely fast-moving particles, but there are only a handful of them in each cubic meter, then even though each particle is moving very fast, there are so few of them that they simply cannot transfer much energy to anything they hit. It is like standing in a snowstorm made of only 3 snowflakes. Each snowflake might be moving at 100 miles an hour, but if only 3 of them ever touch you, you will not feel cold. You will barely feel anything at all. That is what interstellar space is like. The particles around Voyager 2 are moving fast enough to register at tens of thousands of degrees. But they are so thinly spread, roughly a tenth of a particle per cubic centimeter on average in the region Voyager 2 entered, that the total energy they can deliver to the spacecraft is negligible. Voyager 2 does not feel the heat. Voyager 2 feels almost nothing at all. It simply notices and measures and sends the numbers home, but there is something else, something more subtle and more haunting that came out of that crossing. Voyager 1's crossing 6 years earlier had been rougher, more turbulent, more complicated than anyone expected. There were what the scientists called precursor events, small excursions across the boundary, false starts, where the spacecraft seemed to have crossed and then found itself back on the sun's side, then crossed again. It took months to be sure the crossing was real. The heliopause from Voyager 1's data looked frayed, untidy, full of eddies and whirls. Voyager 2's crossing, by contrast, was sharp, clean. In a single day, the transition happened and it stayed. The plasma density jumped. The magnetic field direction rotated. And most strikingly, the flux of cosmic rays, the high-energy particles that come streaming into our solar system from ancient supernovae and other violent events across the galaxy, jumped upward by a huge amount. Because the heliosphere, that bubble of solar wind, had been shielding the inner solar system from those cosmic rays for 4.5 billion years. And once Voyager 2 stepped outside the shield, it felt the full weight of the galaxy's ambient radiation for the first time. Now here is a thing worth sitting with. That shield, the heliosphere, that bubble of solar wind, is not just a curiosity. It is part of the reason life on Earth has been possible. Cosmic rays, the high-energy particles blasting in from across the galaxy, damage DNA. They ionize atoms. They shred delicate biological machinery. The atmosphere shields us from most of them at the surface, yes. But the heliosphere shields the entire inner solar system from an even larger flux of them before they ever reach the atmosphere. Every living thing on Earth, every fish, every tree, every human, has spent its entire existence inside a bubble that a slow, quiet star has been blowing around us for billions of years. And Voyager 2, on that day in November of 2018, was the second human-made object ever to step outside it. The two crossings, Voyager 1 and Voyager 2, also happened at very different points on the heliosphere's surface. Voyager 1 crossed to the north of the ecliptic, the plane in which the planets orbit. Voyager 2 crossed to the south, and the two crossings were about 6 years apart. When we compare the data, we find something strange. The heliopause is not the same shape on the north side as on the south side. It is thicker or thinner in some places. It has an asymmetry, and that asymmetry is telling us something about how our sun is moving through the wider interstellar wind. How the bubble is being pushed and shaped by the flow of gas outside it, the way a soap bubble held in front of a fan gets pushed and stretched by the moving air. Because our sun is moving, right now, right this second. Our entire solar system, the sun, the planets, the asteroid belt, the comets, all of it, is racing through the galaxy at a speed of about 230 kilometers per second relative to the center of the Milky Way. And it is moving through a wind of interstellar gas at a relative speed of about 26 kilometers per second. The heliosphere, that bubble of solar wind, is being blown against that flow like a jellyfish drifting through an ocean current. And it has a leading edge, where the sun is running into new gas, and it has a trailing tail streaming out behind us. Voyager 1 and Voyager 2 both crossed the leading portion, the nose of the bubble. What lies in the tail, no spacecraft has ever seen or ever will. So this is where Voyager 2 stood in November of 2018. On the far side of a wall it could not see, inside a temperature it could not feel. Under a rain of cosmic rays it had never felt before. Surrounded by plasma 20 times denser than what it had left behind, plasma made not of the sun's exhale, but of the ambient breath of the galaxy itself. A cold, ancient, thin gas that had been drifting between the stars long before our sun was born. Voyager 2, for the first time, was no longer inside the sun's territory. It was in the space between, and its instruments kept listening. Now, before we go further, I want you to sit with something. Because I think the wall of fire, the heliopause, is one of the most extraordinary things we have ever discovered, and almost no one on Earth ever thinks about it. Every day of your life has been spent inside a bubble blown by a star. Every breath you have ever taken, every night you have ever slept. Every conversation, every meal, every heartbeat, every moment of grief or joy in the entire history of your species has happened inside that bubble. And there is an edge to it. There is a boundary, and that boundary is a place. It is a real, physical place, with a temperature and a density and a magnetic field. And if you could somehow travel there in a human lifetime, you could reach it. So let me ask you this. If you could stand at the edge of our sun's territory at the wall Voyager 2 crossed, for just 1 minute before turning back, what do you think you would feel? Not physically. You would feel almost nothing physically. Emotionally. Would it feel like standing at the edge of a shore, looking out over an ocean? Would it feel like standing at the edge of a forest, looking out across a clearing? Or would it feel like something else, something we do not have a word for yet because no human has ever stood at the edge of a star's territory and looked out? Sit with that image, because Voyager 2 did it, not for a minute. It is still doing it. It is still moving. It is still measuring. It has been on the other side of the wall for more than 7 years now. And what it has been recording in that time is stranger than the crossing itself. Because on the other side of the wall, in the space between our star and the next, there is a sound, a hum, a vibration in the plasma so faint that no one had ever detected it before, so persistent that once we heard it, we could not unhear it. Voyager 2, on the far side of the wall, discovered that interstellar space is not silent. That is where we go next. To hear something in space, you first have to redefine what hearing is. There is no air between the stars. Not really. Not in any sense your lungs would recognize. And so there is no sound in the way you know sound. No pressure waves rolling through molecules of oxygen and nitrogen. No vibrations traveling through water or wood or bone. The interstellar medium is too thin for any of that. If you were somehow to open a window on Voyager 2 and stick your head out, you would hear nothing at all. Perfect, absolute silence. And yet there is a hum. To understand how that is possible, you have to understand what Voyager 2 actually carries. Because among all the instruments bolted to its spindly frame, there is one that almost no one talks about, one that does not take pictures, does not send back beautiful color images of alien moons, does not deliver anything a documentary can put on screen. It is called the plasma wave subsystem, and it is, in a strange and beautiful sense, an ear. What it hears is not sound. What it hears is the vibration of plasma. The rippling, oscillating, undulating motion of charged particles as they push and pull against each other in the thin gas of interstellar space. When plasma is disturbed, when a shockwave from a distant solar flare rolls through it, when a cosmic ray blasts by, when the ambient gas is compressed or rarefied by some faraway event, the electrons in that plasma begin to oscillate. They wiggle, they wave, and those waves have frequencies. Some slow, some fast, some so faint they can barely be detected. And Voyager 2's plasma wave antennas, two long thin rods sticking out from the body of the spacecraft, 10 meters long each, arranged in a V, feel those waves the way your inner ear feels the vibrations of a drum. The instrument records those oscillations as electric signals. And those signals, when we translate them into the range of frequencies the human ear can perceive, sound like something. Not like anything on Earth exactly. Not like wind, not like water, not like a voice, but like a hum. A steady, faint, persistent hum. The kind of sound you might hear if you pressed your ear against a very old, very cold machine that was still, somehow, running. For decades, while Voyager 2 was still inside the heliosphere, the Sun's territory, the plasma wave instrument mostly picked up chaotic bursts. solar wind pressure fluctuations, shock waves from the sun, a messy, noisy, active soundscape dominated by whatever our star was doing at the moment. But after Voyager 2 crossed the heliopause, after it passed through the wall of fire, something happened. The chaos quieted, and in the new silence a new sound emerged. Faint, constant, persistent, a background tone that did not go away. Voyager 1 had detected something similar a few years earlier on its own side of the crossing, but the interpretation had been uncertain. Some scientists thought the signals might be transient, might be tied to specific solar events, might fade over time. Then Voyager 2 crossed, and its plasma wave instrument confirmed what Voyager 1 had hinted at. There is a hum. It is not going away. And it is not coming from the sun. It is coming from the interstellar medium itself. Sit with that for a moment. The space between the stars, the empty dark that surrounds every star system in the galaxy, is vibrating, faintly, constantly, everywhere. It is not silent. It has never been silent. And every one of us, all our lives, has been surrounded by that vibration, filtered out by the heliosphere, but always there, just beyond it, humming to itself in the dark like an old machine no one remembered to switch off. What is causing the hum? The best current explanation is that it is a kind of gentle plasma oscillation, driven by the ambient density of electrons in the interstellar medium. The plasma has a natural frequency, the way a bell has a natural frequency, or a tuning fork or a taut string. When any small disturbance ripples through it, the electrons oscillate at that frequency, and the oscillation persists faintly for a long time. So the hum is, in a way, the sound of interstellar space ringing at its own resonant note, a note that has been ringing for billions of years, a note that will ring for billions more. And here is where it gets stranger. Because the interstellar medium, once imagined as a featureless void, turns out to be a landscape. We are still, right now, trying to understand what shapes that landscape. Some of the structure may be turbulence, left over from ancient shock waves that rolled through this region of the galaxy long ago. Some of it may be the pressure imprint of the heliosphere itself, pushing outward against the local gas, deforming it, leaving a wake in the plasma the way a boat leaves a wake in water. Some of it may be the fossil signatures of nearby supernovae, stars that exploded within a few hundred light years of us, hundreds of thousands or millions of years ago, whose shock waves are still, faintly, echoing through the medium. Voyager 2, in other words, is not just hearing the interstellar medium. It is mapping it, one measurement at a time, one faint pressure ripple at a time, slowly, painfully, patiently. And it has been doing this now for more than 7 years, ever since it crossed the wall. And there is another discovery, one that hit almost as hard as the hum. The cosmic ray flux. Once Voyager 2 was outside the heliosphere, no longer shielded by the sun's magnetic bubble, it began to feel the full weight of the galactic cosmic ray population. High-energy protons, atomic nuclei, particles accelerated to nearly the speed of light by ancient supernova shock waves, by the magnetic environments of neutron stars, by processes we do not fully understand. These particles rain in from every direction. They come from everywhere. And their flux, once measured cleanly outside the heliosphere, turned out to be higher than most models had predicted. Not dramatically higher, but higher enough that it forced a rethinking of some models of the heliosphere's structure. Because the fact that cosmic rays were somewhat higher outside than expected meant that the heliosphere had been shielding us even more effectively than we had realized. That gentle bubble of solar wind that surrounds our star had been keeping out even more of the galaxy's incoming radiation than we had previously calculated. And for 4.5 billion years, everything that has lived on Earth has been quietly protected by that bubble, in ways we are still, right now, learning to appreciate. But it is the hum I keep coming back to. Because I think there is something almost unbearably beautiful about it. Not beautiful in a sentimental way. Beautiful in the way certain quiet, unadorned truths are beautiful. That the universe in the places between the stars is not silent. That it hums. That it has a resonant tone, a frequency, a kind of low, patient song. That the darkness we look up at every night, the black between the pinpricks of light, is not empty and not dead. It is thin, yes. It is cold, yes. But it is alive with a slow, faint music that no ear on earth will ever hear directly. And a small machine, a spacecraft older than most of the people watching this, is out there right now, 12 billion miles from home, its long antennas trembling to the note of the galaxy. I want to sit with that for a moment. Because if you have ever wondered whether the universe is indifferent to you, whether it is a cold and empty place with nothing but rock and vacuum, I want to offer you a gentler picture. A picture in which even the space between stars has a voice. Not a voice that speaks, not a voice that means anything, but a voice that exists, a vibration, a ringing. A hum that has been going on since long before you were born and will go on long after you are gone, and yet is, in some strange sense, still real, still happening, still there for anyone patient enough and careful enough to listen. Voyager 2 was patient. Voyager 2 was careful, and Voyager 2 listened. Now let me ask you something. If interstellar space has a sound, if the darkness has a low, faint hum, what do you imagine it feels like to hear it in the dark with your eyes closed alone? Does it feel unsettling? Does it feel comforting? Does it feel like something you have almost heard before, in a dream, in the quiet just before sleep, in the hush of a room after everyone has gone to bed? Because I think, in a way none of us can quite prove, we have all been listening for that hum all our lives without knowing it. It has always been there, just beyond the wall, just outside the bubble, waiting for someone to notice. But here is the twist. Because as extraordinary as the hum is, as strange as the wall of fire is, as unexpected as the density landscape of the interstellar plasma turned out to be, all of it, every piece of it, is happening inside something even larger, something we are only just beginning to map, something that changes the meaning of the phrase interstellar space entirely. Because Voyager 2, when it crossed the heliopause, did not enter the general Milky Way. It did not step out into the average interstellar medium. It stepped into a very specific, very local pocket of gas. A small, wispy cloud that our sun happens to be passing through at this exact moment in cosmic history. A cloud that is itself embedded inside a much larger structure. A cavity, a bubble. A cavern in the fabric of the galaxy so vast that everything we can see with our naked eyes at night, every star, every constellation, every pinprick of light in the sky is inside it with us. We live inside a hollow, and that hollow was carved by fire, by ancient fire, by stars that died before humans existed. And Voyager 2 is drifting, right now, through a region of space that is not really the galaxy at all. It is the aftermath of a violence we can barely comprehend. That is where we go next. Zoom out. Just for a moment. Leave Voyager 2 hanging in the plasma, its antennas trembling to the hum, and rise upward in your mind above the plane of the solar system. Above the ecliptic, above the sun. Watch the planets shrink into a tight, small disk beneath you. Watch the heliosphere, the great teardrop-shaped bubble of solar wind, become a bright, pale shape a few times larger than the planetary orbits. Keep going. Watch even the heliosphere shrink until it is a small, glowing dot in the darkness. And now, when you look around, you see something you have never seen from the ground. You see the shape of the cloud we live inside, because our sun is not floating in empty interstellar space. Not really. It is inside a small, wispy cloud of gas. A very thin, very diffuse, very unimpressive-looking cloud, if you could see it, which you cannot, because it is far too tenuous to reflect any visible light. This cloud has a name. Astronomers call it the local interstellar cloud. Some of them, more casually, call it the local fluff. The local fluff is about 30 light-years across. Small by galactic standards, very small, and its density is astonishingly low, roughly 1/10 of a hydrogen atom per cubic centimeter on average. To put that in perspective, the air you are breathing right now contains something like 10 quintillion molecules per cubic centimeter. The interstellar cloud you and your entire species have been sailing through for the last 60,000 years or so is thinner than the best laboratory vacuum by an almost unimaginable margin. But it is there. It has a shape. It has a temperature, about 6,000 or 7,000 Kelvin, warmer than you might expect. And our sun is drifting through it, along with a handful of nearby stars, all of us swept up together in this small parcel of gas, moving as a group through the wider galactic neighborhood. Voyager 2, when it crossed the heliopause in 2018, did not enter interstellar space in the general sense. It entered the local interstellar cloud. It stepped from the sun's bubble into the fluff. And now here is where the story cracks open. Because the local fluff, small and thin as it is itself sitting inside something much, much larger. Something so vast that the fluff and our sun and Voyager 2 and every star you have ever seen with your naked eye are all inside it. A cavity, a hollow. A cavern in the fabric of the galaxy. This structure has a name too. Astronomers call it the local bubble. The local bubble is roughly 1,000 light-years across, 10,000 trillion kilometers more or less. A void of relatively hot, relatively low-density gas, carved into the surrounding, denser interstellar medium of the Milky Way. If you could somehow view our region of the galaxy from far above the galactic plane, you would see a great, roughly peanut-shaped cavity, with walls of denser gas around it, and inside that cavity, drifting like dust motes in an empty room, thousands of stars. Our sun near the center, the nearby star Alpha Centauri, Sirius, Procyon, Vega in the constellation Lyra, every bright familiar star that has hung in your sky since you were a child, all of them together inside the bubble. All of them born inside it, or drifted into it, or been swept along by the currents of the galaxy in ways so slow no human being will ever perceive them. And here is the part that changes everything. Because the local bubble is not a natural feature of the galaxy, it is not the way galaxies just are, it is a scar. It was made by explosions, by many explosions, ancient ones. When a large star reaches the end of its life, in a rare and violent event called a supernova, it does not simply die, it detonates. Its outer layers are blown outward at thousands of kilometers per second, ripping through the surrounding interstellar medium, compressing gas, heating it, driving a shockwave outward for centuries and millennia. A single supernova can carve a cavity in the surrounding gas a few hundred light years across. And if you have several supernovae from a cluster of massive stars all born together and dying together over a few million years, their overlapping shockwaves can hollow out a much larger cavern, a bubble, a void. That is what the local bubble is. The best current evidence, based on careful mapping of the stars in our neighborhood and modeling of their motions backward in time, suggests that the local bubble was carved out by somewhere between 15 and 20 supernovae, over a span of maybe 10 to 15 million years, beginning something like 14 million years ago. A cluster of young, massive, short-lived stars, moving as a group through this region of the galaxy, died one after another in a slow, sequential cascade of explosions. Each explosion drove its shockwave outward. The shockwaves merged. Together they swept the gas of the surrounding medium away, piling it up into the dense walls of the bubble, leaving the interior hot, thin, and relatively empty. And it is inside that hollow, inside the aftermath of those explosions, that our entire solar system sits. Let me try to make this feel real, because I think most people, when they hear numbers like 15 supernovae and 14 million years, hear those numbers as abstractions, as tidy scientific facts. So let me anchor it in something you can hold. 14 million years ago on Earth, there were no humans. There were no apes recognizably like us. The world was populated by early hominoids, by ancient horses, by mastodons whose bones we occasionally find. The Andes were still rising. The Mediterranean was almost, but not quite, the shape we know today, and somewhere in the sky above them a supernova was going off, then another, then another. Each of them a burst of light bright enough that, if any of our ancestors had been looking, they would have seen a new star in the daytime sky, brighter than the moon, lingering for weeks before fading. The gas of the galaxy around us was being shoved. And by the time the last of those explosions had ended, several million years later, a cavity had been carved. A cavity that our sun, still moving slowly through the galaxy on its own long orbit, would eventually drift into. We arrived at this address in this hollow only in the last few million years. We are guests in a cavern someone else's death made, and inside that cavern we found a small cloud, the local fluff, adrift within the larger emptiness. Where the fluff came from is not entirely clear. Some astronomers think it may itself be a piece of ejected material from one of those ancient supernovae, still lingering, still drifting, its shockwave long spent, its gas cooled to the temperature we measure today. Others think it may be a small, unrelated wisp that has floated into the bubble from outside. What is clear is that we and Voyager 2 are inside both. We are inside the fluff, which is inside the bubble, which is inside the Milky Way, which is inside the local group, which is inside a larger supercluster of galaxies, which is inside the observable universe. Each layer is embedded in the next. Each layer once we thought was the whole story. Each layer we now know is only a small pocket in something vaster. And that fact that we live inside the aftermath of ancient stellar deaths changes something. It changes the way I look at the night sky. Because when you look up on a clear, dark night and you see the stars, you are looking at points of light inside a cavity that fire made. The blackness around them is not the ordinary blackness of the average galaxy. It is the blackness of a hollow, a cavern, a place where the gas was blown away long ago and never came back. Every constellation, every familiar shape is drawn on the inside of a wound. That is not a nihilistic thought. I want to be careful. It is not a thought that says we do not matter, or that the universe is violent and indifferent. It is a thought that says something more complicated, that we and everything we love exist because of what happened before us. That the calm, dark sky above your house tonight is calm and dark precisely because 14 million years ago, other stars died so completely and so violently that the space around them was, in a sense, cleared, made room, left in emptiness that a small, slow, quiet star, our sun, could eventually wander into and set up a household. Life on Earth, in a certain sense, was made possible not just by our sun, but by the corpses of stars that never met us and never will. And Voyager 2 is drifting through the aftermath. It is not entering the general galaxy. It is not stepping out into the average interstellar medium. Not yet. Not for a very long time. Right now, and for many thousands of years to come, it is still inside the local fluff. And after it leaves the fluff, if it ever does in any time frame we can measure, it will still be inside the local bubble. It will not exit the bubble for something like 100,000 years. It will still be, in a certain sense, inside the same hollow we live inside now, sharing the same cavern, adrift in the same fossil. And there is one more thing, and this is where the reframe really begins. The local bubble is not still. It is not permanent. It is drifting, deforming, aging. Its walls are dissolving very slowly back into the surrounding medium over tens of millions of years. And our sun, along with its passengers, all the planets and the little machines we have launched, is not sitting in the center of the bubble. It is moving at its own slow galactic pace, and it will not always be here. In another few 100,000 years, our solar system will exit the local fluff and enter a different, thinner region of the bubble. In a few million years, we may exit the bubble entirely and enter the denser gas of the surrounding galactic arm. When that happens, our heliosphere will change shape, compress, become smaller. The shielding it provides against cosmic rays may weaken. The environment at Earth's surface will change, subtly, in ways it is very difficult to predict. All of this is happening, slowly, invisibly, in real time. And here is the strangest thought of all. Voyager 2, drifting outward at 15 kilometers per second, is a passenger on this migration. It is being carried, along with the entire solar system, by the sun's motion through the galaxy. It is drifting away from us relative to the sun, yes, but relative to the wider galactic neighborhood, it is drifting with us. It is one of us. It is a piece of Earth carrying a golden record from our world, riding the same slow current through the cavern that the rest of us are riding. For now, for as long as any of us can see. So let me ask you this. Does it change how you feel about the night sky, knowing what you know now? Knowing that the darkness above your house is not the ordinary darkness of the average galactic sky, but the specific darkness of a cavity carved by ancient explosions. Does the sky feel different when you think of it as a wound that healed into a cathedral? Does it feel gentler, or lonelier, or more sacred, or all three at once? Sit with that, because we do not often let ourselves feel the sky. We are usually too busy to look up, and when we do, we are usually not thinking about hollows and bubbles and the deaths of stars that made room for us. But it is all real. It is all above you right now. And Voyager 2 is out in it, quietly, patiently, still recording. And now we come to the part of the story that is the hardest to tell, because Voyager 2 is not immortal. It is, in a way, already dying. Not all at once, slowly, one instrument at a time, 1 watt of power at a time. And the engineers who care for it, the small team who have kept it alive across nearly half a century, are counting down the years, the months, the weeks, until the final whisper fades below the noise, and Voyager 2 becomes something no human-made object has ever quite been before. It becomes a fossil, and what a fossil is and how long it lasts and where it will drift after we can no longer hear it is stranger and more haunting than anything we have discussed so far. That is where we go next. There is a small chamber deep inside Voyager 2 that has been keeping the spacecraft alive for nearly half a century. It is not a battery. It is not a solar panel. Solar panels would be useless out where Voyager 2 lives, because the sun, from that distance, is little more than a bright star, not a source of power. Instead, Voyager 2 carries something older, quieter, and stranger. A small block of a radioactive isotope called plutonium-238. Not the kind used in weapons. A different isotope, one that does not fission but that decays. Slowly, steadily, predictably. Every atom of that plutonium on its own timetable releases a tiny burst of energy as it transforms into another element. And that energy, gathered up by a set of thermocouples that convert heat directly into electricity, is what powers the spacecraft. At launch in 1977, the plutonium generators inside Voyager 2 produced about 470 watts of power. Not much. Roughly the amount of energy you would draw from 4 modern light bulbs, but enough to run the instruments, warm the electronics, and drive the transmitter that has been whispering back to us across the decades. That power has been fading. Every year the plutonium decays a little more, delivers a little less heat, produces a little less electricity. And every year the engineers who care for Voyager 2 have to make a choice. Something has to be turned off. Something has to be sacrificed to keep the rest alive. A heater here, a subsystem there, an instrument that has done its job. For decades this decline was gentle, barely noticeable. There was slack in the system, room to lose a little power and still keep everything running. But by the mid-2020s that slack was gone. The power budget became tight, then tighter, and the engineers began making the kinds of decisions that must feel, if you have spent your career caring for a machine, like small acts of mercy performed at a distance. In 2024 and 2025, one by one, several of Voyager 2's remaining active instruments were switched off. The plasma science experiment, the same instrument that had recorded the crossing of the heliopause in 2018, the one that gave us the direct measurement of the temperature and density on the far side of the wall of fire, was powered down. Its work was, for the most part, done. Its data had already reshaped our understanding of the boundary of the sun's territory, and it was consuming power the rest of the spacecraft needed, so they turned it off, gently, and Voyager 2 continued a little quieter than before. More instruments will follow. The cosmic ray subsystem, the low-energy charged particle experiment, the plasma wave subsystem, the one that hears the hum. All of them, one by one, over the coming years will be switched off, not because they are broken, but because there is not enough electricity left to run them. Each shutdown will be a small loss for the science community. Each shutdown will be the end of a particular kind of listening, a particular kind of ear that has been open to the universe for almost 50 years. And then, sometime in the early 2030s, if the plutonium continues to fade at the rate we expect, the last instrument will be shut down. The magnetometer, maybe, or the plasma wave antennas, whichever one is chosen last. And after that, Voyager 2 will still transmit for a little while longer, sending back what is called engineering telemetry, information about its own state, its own temperature, its own orientation. But no more science. No more measurements of the plasma or the cosmic rays or the magnetic field. The listening will be over. And then, eventually, sometime later still, the transmitter itself will fail. The whisper will fade below the noise. There will be a final signal, though we may not recognize it as the final one when it arrives. There will be some last day, some last 22-watt trickle of radio energy, arriving at Canberra after its 20-hour journey through the dark, and the engineers will process it and add it to the archive and go home. And the next day, there will be no signal. And the day after that, no signal. And gradually, we will realize that we have received the last message, that the conversation after nearly 6 decades is over. Voyager 2 will go dark for the final time. Not because of a wrong command or a broken antenna or a hardware fault, because it has, at last, run out of the small, quiet fire that kept it awake. And here is the thing that I want you to sit with, because I think it is the strangest and most beautiful and most haunting fact in this whole story. When Voyager 2 goes dark, it will not stop. It will not slow. It will not decay. It will not fall. It will keep moving at 15 kilometers per second, 9 miles every second, forever, or something so close to forever that the difference does not matter in any human sense, because there is nothing out there to stop it, no air to create drag, no planet to pull it in, no star for a very long time close enough to bend its path significantly. Voyager 2, once it goes silent, will continue in essentially the same direction, at essentially the same speed, for a length of time so long that the human mind rebels against holding it. Let us try to hold it anyway. Let us try together to walk the path Voyager 2 will follow after we can no longer hear it. In about 40,000 years, roughly 1,000 human generations from now, Voyager 2 will pass within about 1.5 light years of a small, faint red dwarf star called Ross 248 in the constellation of Andromeda. Not a close encounter in any dramatic sense. Ross 248 will be, at that moment, roughly 10 trillion kilometers away from the spacecraft. But by the standards of interstellar distances, that counts as a passage. Ross 248 will be, briefly, the closest star to Voyager 2 at that moment in time. 40,000 years. Try for a moment to hold that number. 40,000 years ago on Earth, our species had just barely spread from Africa across Europe and Asia. There were no cities, no agriculture, no written language. There were still Neanderthals living alongside us in the same forests, the same valleys. The last ice age was in full grip. The world was cold and small and full of animals we have never seen. And Voyager 2 will take that same span of time, 40,000 years, all of that from cave paintings to now, and then some, to travel to a place that is not even, in cosmic terms, particularly far. But it will keep going. In roughly 296,000 years, give or take, Voyager 2 will pass within about 4.5 light years of Sirius, the brightest star in our sky. Sirius, that fierce blue-white beacon that has hung above every civilization, every empire, every generation of humans who have ever looked up. Voyager 2 will pass Sirius, at a distance close enough that if there were any beings orbiting Sirius who were watching for interstellar debris, they might, in principle, detect it. Not that they would recognize it, not that they would know what to make of it. A small piece of metal and gold, moving on a strange trajectory, silent, cold, drifting, almost 300,000 years. Try to hold that too. 300,000 years ago, our species did not exist in its current form. Homo sapiens was only just emerging in Africa. All of recorded human history, every pyramid, every cathedral, every book, every song ever composed by our species, fits inside the last few thousand years. And Voyager 2 will still be traveling, still coasting, still carrying its golden record, 300,000 years from now, longer than we have existed. Longer than we will, in any current form, probably continue. And it does not stop there. Voyager 2 will continue drifting through the galaxy for millions of years, tens of millions, hundreds of millions. In 4 billion years, roughly, our sun will begin to swell into a red giant. Its outer layers will expand. Mercury will be swallowed. Venus will be swallowed. Earth itself will most likely be scorched to a lifeless husk, if not consumed outright. The oceans will boil. Every trace of civilization, every fossil, every pyramid, every seed vault, every gold-plated record that has ever been sealed in a granite vault on Earth will be erased. Our planet, as anything recognizable, will be gone. And Voyager 2 will still be moving, somewhere out in the galaxy. Drifting slowly through the halo of the Milky Way, following its own long, quiet orbit around the galactic center, will be a small piece of metal gently pitted by billions of years of micrometeoroid. Impacts its surfaces, darkened its once shiny components dulled to a soft gray, but still intact. Still holding its shape, still carrying, bolted to its side, a copper disc plated in gold, engraved with the greetings of a species that had, by then, been gone for billions of years. Voyager 2 will outlive Earth. It will outlive the Sun. It will outlive the human species, in every scenario we can currently imagine. It will drift among the stars for periods of time so long that new stars will be born and die around it. It will pass through gas clouds. It will feel the pressure of ancient supernovae. It will circle the center of the galaxy hundreds of times, and it will still be there, still moving, still carrying its record, a fossil launched by a species that did not yet know what it was making. Now, here is what I keep thinking about. When we launched Voyager 2 in 1977, we imagined the golden record as a message to aliens, a greeting, a hope, in case someone somewhere ever found it. And that is a beautiful idea. But the odds, honestly, are vanishingly small. The galaxy is enormous. Interstellar space is enormous. The chance that Voyager 2 will ever be intercepted by any intelligent species is so low that we cannot really calculate it in any meaningful way. But the record is not, in the end, only a message to aliens. It is a message to time. It is a message that says we existed. On this small planet, in this small pocket of the galaxy, inside this small bubble carved by ancient explosions, there was, for a brief moment, a species that could dream, that could look up at the stars and want to reach them, that could build a machine and let go of it, that could carve its songs and its laughter and its languages onto a disk of copper and gold, and cast that disk into the dark, not because it expected an answer, but because it needed to try. Voyager 2 is our attempt to leave a fingerprint on the universe, to say that we were here, and it will succeed. even if no one ever finds it, even if it drifts, silent, unread, unopened for the rest of the age of the universe, it will succeed. Because it will exist, because it will keep moving, because for as long as there is a galaxy in any recognizable form, some part of us will be inside it, moving with it, carrying a little of what we once were. So let me ask you something. If Voyager 2 outlives our species, and I think there is a very real chance that it will, what do you hope it says about us? Not in words, not in music, in the fact of it, in the pattern of it, in the choices we made when we sealed that record and let it go. Do you hope it says that we were curious, that we were kind, that we were, on our best days, worth the effort of remembering? What do you want a stranger, if there ever is a stranger, to know? And what do you want the universe itself, if the universe has any way of noticing, to know about us? Because Voyager 2 is, in a real sense, the most durable statement we have ever made, the most lasting sentence we have ever written. Long after every book has decayed, long after every stone has weathered, long after the Earth itself is a memory, Voyager 2 will still be out there, still saying it. Sit with that. And now, here at the end, we have to ask ourselves something the engineers of 1977 could never have imagined asking. Not because they were not thoughtful people. They were. But because you cannot imagine a question this strange, this quiet, this humbling, until you have followed the story all the way to this point, until you have crossed the wall of fire, until you have heard the hum, until you have understood the hollow we live inside, until you have watched a machine older than yourself run out of the last of its small, quiet fire and continue anyway and keep going and go on and go on. The question is this: what does it mean that we launched a fossil before we knew what a fossil was? And what does it mean that, in the end, going dark is not the same as being gone? That is where we go next. Let us walk it backward. Begin at the end. A small piece of metal drifting in the dark, billions of years from now. Silent, cold, perfectly still relative to the local flow of gas around it, though moving still at 9 miles every second relative to the ancient center of the galaxy. Its plutonium long spent. Its transmitter long gone. Its instruments long silenced. And bolted to its side, a copper disc plated in gold, engraved with the sounds of a species that has, by then, long since ceased to be. A greeting in 55 languages, spoken by voices that no longer exist. A whale song from an ocean that no longer exists. A prelude by Bach from a planet that no longer exists. All of it still there, still real, still in a certain sense waiting. Now step backward in time. Watch the record grow younger. Watch the metal grow smoother. Watch the pits from micrometeoroids close and heal. Watch the darkness around Voyager 2 change. Watch it drift back through the wisps of interstellar gas. It will one day pass through back toward the local bubble, back into the small cloud we call the local fluff. Back through the invisible wall of the heliopause, back into the sun's territory, back past the orbits of Neptune and Uranus and Saturn and Jupiter, and Mars, back to Earth, back to a launch pad in Florida in the summer of 1977. back to a rocket rising into a clear blue sky, back to the moment when a small silver spacecraft holding a golden disk left this planet for the first and last time. You have been carried through this story tonight, from that launch outward. From the postcard we all learned as children, past the two darknesses, through the wall of fire, into the hum, into the fluff, into the bubble, into the fossil. Each layer larger than the last, each layer making the previous one look small. And now, at the end, I want to tell you something that I hope will change the shape of the whole journey for you. Because I think, when we started, we were asking a certain kind of question. And I think now, at the end, that question has quietly dissolved. We began by asking what Voyager 2 was listening to before it went dark, as though going dark were a specific event, as though there were a moment, a boundary, a threshold at which the machine crossed from something to nothing, as though silence were the opposite of speech. But look at what we have actually seen. Voyager 2 has been going dark in a certain sense its entire life. Every year a little dimmer, every year a little quieter. Every year one more instrument shut down, one more subsystem powered off, one more small mercy performed at a distance. And when the final signal fades, that will not be an event. It will be the last visible flicker of a fading that has been going on continuously since 1977. Voyager 2 will not at any single moment go dark. It is going dark now. It was going dark then. It has always been going dark. And that is not sad. That is just what it means to be a physical thing, made by finite hands, given a finite fire, sent out into a place too large for any finite fire to last. And the other side of that. Because when we say Voyager 2 will go dark, we usually mean it will stop speaking to us. But Voyager 2 was never really speaking to us in the way that phrase suggests. It was not composing messages. It was not choosing what to say. It was, in a certain sense, only ever letting us listen. Its instruments recorded whatever was there. The hum, the plasma, the cosmic rays, the magnetic field, the little variations in density in the interstellar medium, all of it unfiltered, unedited, unmeaning. Voyager 2 was a small, patient ear, held open, and everything it ever transmitted back to us was, in the deepest sense, not its voice. It was the universe's voice. Voyager 2 was only the medium. And that voice, that thin, quiet, patient hum of the interstellar medium, does not stop when Voyager 2 goes dark. It has been going on for billions of years. It will continue for billions more. What ends when the spacecraft finally falls silent is not the sound. It is only our ability to hear it, from that particular listening post, at that particular position, in that particular pocket of the galaxy. The universe does not stop humming. We only stop being told about the humming from that one spot. So the question we started with, what was Voyager 2 listening to in the seconds before it went dark, quietly dissolves. Because there were no seconds before it went dark. There is no going dark, only a fading. And there is no listening, only a passing through. Voyager 2 was never really our voice thrown into the void. It was the void's voice, briefly amplified and now returning gently, gently to its natural volume. I want you to sit with that, because here is what I think is the tender part of this story. And I want to say it carefully because it is easy to get wrong. It would be easy to hear all of this and feel small, to feel that we are nothing, that the universe is enormous, and we are momentary, and the machines we build are dust, and the fossils they become will drift for billions of years past stars that will not notice them. It would be easy to hear this and feel a kind of quiet despair. I do not want you to feel that. I do not think that is what this story teaches, because look at what happened. A species that has existed in its recognizable form for maybe 300,000 years, on a small planet, inside a small bubble, inside a wisp of gas, inside a hollow carved by ancient stars, looked up. It looked up. It saw the planets. It saw the stars. It counted them. It gave them names. It calculated their orbits. It figured out, from a small blue-green world at the edge of a middling galactic neighborhood, that there was a grand tour possible in 1977 that would not come again for 176 years. And it built a machine. It sealed a record. It let go. And 48 years later, that machine is still working, still whispering, still carrying our songs into the dark. That is not the story of a species that does not matter. That is the story of a species that, on its best days, is capable of something almost unreasonable, almost impossibly hopeful. The Voyager engineers did not know if any of it would work. They did not know if the spacecraft would survive to Jupiter. They did not know if it would see Saturn. They certainly did not know if it would cross the heliopause 4 decades later and become the second human-made object ever to leave the sun's territory. They just built it, as carefully as they could, and they let go. And you and I, tonight, are the inheritors of that letting go. Voyager 2 is still whispering. It is still whispering right now as you listen to this. 12 billion miles away, at this exact moment, that small machine is transmitting a 22-watt signal that will arrive on Earth about 20 hours from now and be caught by a dish in Australia and be added to the archive. And a small team of engineers, some of them older than the mission itself, will look at the data and check the health of the spacecraft and send a message back, every day, still, for as long as they can. And you are, right now, in a small way, part of that inheritance. You are inside the same bubble. You are drifting through the same fluff. You are looking up at the same stars from a slightly different angle than the ones the Voyager engineers looked at in 1977, but the same stars. Sirius, Vega, Alpha Centauri, all of them still in the sky above you, all of them still in the same cavern. All of them, in a way, keeping you company from a distance. The universe is not indifferent to you. The universe is not hostile. The universe is only large. It is only patient. It is only slow. And in the middle of that largeness and patience and slowness, small conscious creatures like you have somehow, against very long odds, managed to exist to look up to wonder, and to send a small piece of themselves outward into the dark, not because they expected an answer, but because they needed to try. Voyager 2, when it finally goes silent, will not be gone. It will only be quiet. And quietness, we have learned tonight, is not the same as absence. There is a hum in the interstellar medium that has been going on since long before we existed. There will be a spacecraft in the interstellar medium, drifting silently, carrying a golden disk, that will continue long after we are gone. Both of these things are true at the same time. Both of them, in a certain way, comfort me. I hope they comfort you too. Before I let you go, I want to ask one small favor, the same one I asked at the beginning. If this kind of slow, careful, patient exploration is the kind of thing you love, if you have made it all the way here, into the last few minutes of this journey, then a like or a subscribe or a small kind comment helps this channel keep making these long, quiet videos. It is a small thing on your end. It is an enormous thing on mine. Thank you sincerely for staying with me this long. And now, one last question before we say good night. When Voyager 2 finally goes silent, sometime in the next handful of years, do you think we will feel it? Not intellectually, not scientifically. Do you think, somewhere deep in the collective quiet of our species, we will feel the moment when the last whisper fades below the noise? Do you think there will be a small, unnameable weight in the world on that day, even for people who never knew the mission was there? I do not know the answer. I only know that I think, in some small way, we will feel it. And that feeling, whatever shape it takes, will be a kind of goodbye we owe to something that has been quietly listening for us all this time. But not yet. Voyager 2 is still speaking. Voyager 2 is still whispering at this very moment. Into a dish in the hills outside Canberra, at nearly 136 times the distance from the Earth to the Sun, moving outward at 15 kilometers every second into a cloud, inside a bubble, inside a galaxy, inside a universe that hums to itself in the dark. And you, small conscious creature that you are, get to know about it, get to sit with it, get to hold it in your mind tonight as you drift toward sleep. That is a good thing to hold. The stars above you are older than you can imagine. The bubble around you was carved by fires that went out before your species was born. The hum of the interstellar medium is playing, right now, just beyond the wall of your sun's small territory, at a frequency no human ear will ever hear directly. And a small piece of us, a small silver spacecraft with a golden disk on its side, is out there in it, listening patiently, carefully until the last of its small, quiet fire fades. You are safe. You are small. You are here. And the universe, in its enormous and patient way, is humming. Sleep well under the stars. Good night.